Hey everybody, so today we are going to be going over a practical example for where you have a knowledge graph, and in our case it's going to be teeny tiny itty bitty little knowledge graph, and I'm going to show you some brief examples of what that looks like. And when you pair that with an AI RAG operation and the improvement that you can get from adding the verifiable information into your RAG operation gives you better AI responses. The other thing we're going to talk about is how it decreases the risk associated with AI responses that don't have that level of detail available. Oftentimes they're very vague. And while vague doesn't necessarily mean wrong, it does mean that the response from the AI is up for interpretation. That means it's on us to get it right or wrong. And oftentimes humans get some things wrong. I don't know if you've noticed. So it does add a layer of risk into your AI responses. Okay, so without further ado, let's go ahead and get started and see what we can see. Okay, so as part of this demonstration, you're going to see you don't actually need to have a ton of data to make this work. And that's great if you're trying to prove out if this is something that you yourself want to get involved in. You also don't need a giant graph if you do this in real life. It's really what are the things in your graph or what are the things in your AI responses that you need to get really, really accurate or really, really detailed and have less vagaries. So doing some experimentation to understand where the pitfalls are currently in the use of your AI and the responses that you're getting from it might be all you need to get started. All right, so for this example, we are only going to be working with 3 articles. All of these articles were discovered by me looking for citations amongst the top scholarly research on vitamin C and cancer and what the interplay between those were. So these, as you can see, are some of the top cited articles, at least the time that I was doing this research. So these all have something in common, and these are also open source, so I'm not, ripping anybody off here. So you can see here 2 agree with each other, but their ranges are a little off. So let's go ahead and get our little mini knowledge graph set up. So the first thing that we're going to do is we are going to capture the knowledge to put into a knowledge graph. And this is if it doesn't already exist in your knowledge graph. So in this case, we could use graphRAG or LightRAG and mine out all of the commonalities of this body of research. So I had to go in and determine how I'm going to put a line around a certain body of research. In this case, it's research that is all citing each other about vitamin C and cancer patients. And so if you're using LightRAG and graphRAG, it will then construct a graph-like framework that an AI can use to ground itself off of. But here's the problem. Didn't we just see that there's a conflict? Do we want to leave that up for the AI to decide? Probably not. Do we want to understand what the nuances are in that subfield of information? Probably. Do we want medical professionals to go in and verify that we're not off the wall and crazy? Yeah, absolutely. So you can see here, you can go in and create a statement on what is the most common statement on vitamin C as a positive and vitamin C as a negative. And so that is that summary of all the statements of all the research out there so that you have a triple-like structure you can create from those aggregation of or a summary of those statements. And then that's what you would put into your graph. So this is the structure that we're starting with. We have an entity for vitamin C that we can hang all of these statements that we get from research, from your own organization's documentation, from data sources that you are using externally or internally. Those all can boil down into these statements of node, an entity, and a node, and then you would build this into your graph. So this is the start of what that looks like. And now we're going to layer in that information that we were just looking at about vitamin C and cancer. This is where having a knowledge graph with a more accepted range, maybe an aggregated range from all the other content, all the other research that's out there that's talking about the different ranges and the different pros and cons and the different factors that go into which dosage and ranges would be appropriate, and also human subject matter experts going through and identifying what is accurate and what is correct based on specific domain knowledge. So even though this article doesn't have as many citations, it's certainly not the only article that is talking about a negative effect of vitamin C on cancer patients. So you could take the wisdom of the crowd kind of thing, where, you know, so many citations are saying that there's a positive response of vitamin C and cancer patients, that should be good enough. Except these are people. It's their health, it's their lives. You can't mess this up. And there's enough of a body of research saying something in a negative light that it really behooves you to go in and understand what those nuances are. Because if an LLM is looking at this, and we're going to see exactly what the LLMs do, again, right out of the box, I've done nothing to these LLM responses. We're going to see what they do when they don't have a clear direction on what is the interplay between vitamin C and cancer. There's something there, but if it's a weak signal, there's not a lot of detail, or it's just a really muddy topic, the AI is going to have to pick a winner. And it's not going to want to pick wrong. So if it sees an overwhelming amount of knowledge in one direction or the other, it will come down as neutral, which is where you get a lot of those AI statements and responses that are super vague, where it's almost not even useful. So we're going to go in and look at that. So here you can see that we have both statements represented. One is being verified by all the citation data in the world, but then there's that outlier that has enough substance to it that it might not just be a mistake outlier. It might actually be something that is something we need to pay attention to. And so here you can see we have passed this on to a subject matter expert, and you can do that through human in the loop. Oftentimes people use this from either internal subject matter experts, or you can work with consultants to get some of that detail in, or you can do something with surveys like a SurveyMonkey or a Toloka or something like that, where you can either give it to the crowd for information. So let's say you have a conflict about gardening and you don't need an expert PhD in horticulture to answer it. You need a lot of enthusiasts to give you information on that. Or in this case, you need a medical professional to weigh in on it. And they come back with this research that's saying actually a very specific cancer drug has an interaction with vitamin C that makes it less effective for chemotherapy. Okay, then, that is a very important thing to know. And if we had just went with the knowledge of the crowd, the wisdom of the crowd, we would have completely missed this information, because it's a very small subset of research that's talking about this very specific cancer drug. So now that we have this information, that original unverified statement, because it didn't have enough corroborating evidence from citations, we actually don't want to throw it out now. We now know it's not necessarily verified until we add in this additional context that this specific cancer drug, when combined with vitamin C, can lead to detrimental effect with cancer patients. Now we have not just made our graph more accurate, but now anytime ever that our AI is going to use information about the specific cancer drug or the specific query about cancer drugs and their interactions with vitamin C, it's always going to now have this information available to it. It's not going to have to pick a winner. It's not going to have to query and try to figure out all the vector space around something just to understand this. We have now put this into practice so that it can be repeated and it can be queried and it can make the AI response better. So let's look at what that looks like. All right, so let's look at Exhibit A. So we're looking at 2, and I did the rest of the assessments. It's just too much to put on screen here. But if you're interested, let me know, and I can put that in research somewhere that you can access. But if you look at these responses, and I went through and I annotated them, so if you want to go through and look at the vagaries and the things that are verified, that's the other interesting thing. Even if you don't use this graph information that we just captured, even if you don't put it into a graph, if you don't use this information during your RAG process of your AI responses, this is also showing you that you can use that graph data that we just added to verify AI responses after they're generated. So if you don't want to go through all the hassle of doing RAG, you could put in a process where your graph is verifying based on your organization's information, your SME's information. That might be another approach that you can take. So if you look here, you can see there's a whole lot of vagary going on here. So the confidence is not that high. Now, keep in mind, we are doing this on one set of information that we saw in that little diagram of our graph, our table. That is the only information I have available to me to verify the information in front of me. So anything that does not have a highlight, it can't be verified. Now, that implies if you have more things to verify off of, it increases the confidence. But here, it's just meaning that I don't have enough detail to understand if it's right or wrong. You can see where things are super vague, that it's adding a level of risk. And this is one element of AI responses and quality assessments and other things that I just don't see enough of. There's so much stuff about hallucinations, and yes, that's a problem, and you got to look at it and you got to really understand what you're getting into. But there's another side of this, and that is the vague stuff that so much AI does, because it has a lot of guardrails on it, which is good. But those guardrails also exhibit this behavior where if it just isn't confident, or it deems something too risky or too muddy to represent, it just doesn't. It just gives you a very vague answer. And so that's where some of that risk shows up. And the risks are also captured in things that I can't verify. So eventually, as I build out this graph, since it only has essentially one node that I'm working with here, one node of vitamin C and its statements, eventually I'm going to have more than that, and then I can verify more. So that would increase my confidence and would also decrease the risk. So here is a super basic, super lightweight example of how, if your AI is querying your graph and getting these statements about the context and entities that it sees, it can grab these during retrieval and then use it when it's doing its generation. So you can see what that looks like here, and you can see what's being returned is all of these statements about vitamin C and cancer patients, and specifically things that are potentially detrimental. And that's all happening with your traditional search engine kind of stuff, where the AI is retrieving statements, understanding its relevancy, and then using that during the RAG process to generate a response. So let's look at what that looks like now that we have some additional information for the AI to consult. So here's the full ranking. Now, keep in mind, I am using a teeny tiny data set and a teeny tiny, it's not even a graph. It's just verified statements basically that are in a graph-like form. So you can see here, the risk goes way down. And that's because I can verify more things, and I can see that specificity showing up. And notice, because I gave that very specific information that was missing from before, the AI is using that as part of its grounding to use in its response. And because we also know that that is improving, it's not as vague, it's more specific, and we can also verify that specificity, we can see the confidence going up. Now, this confidence isn't the highest. Like, don't get me wrong, I'm not claiming it's the best thing here. But again, it's 3 documents and a thrown together mini itty bitty graph. So you can see if you then started to build this out. Now, again, there's more complexity there. So you're going to have to do some testing to make sure that the grounding statements that you're putting in aren't actually confusing the AI more than they're solving for. Honestly, that doesn't happen too much if you have good entity resolution. So like there's that. But this is what we're looking at. You can see the specificity here. You can see how the response. Now, again, I did nothing other than just give it this RAG aspect. I didn't do any other parameters. I did nothing else. So it's a long response. So I would want to shorten it up a little bit. But you can see there's an improvement here. And this is just from basic stuff that we just did. So overall, after doing this experiment, it's not a silver bullet. It's not a miracle. These are things that you need to apply tactfully to the AI responses, the data, or the questions that your AI is getting that need to be more precise, have more detail, have higher confidence, that you can verify that confidence, and also decreasing the vagaries that show up. Because after this, this is a very small example, but the confidence increased by 21%. Again, it's not the highest number. I know it can go higher, but this is on a teeny tiny itty bitty data set. And then if you look at the decrease in hallucinations, 59%. 59%. That's amazing. Again, tiny itty bitty data set. So imagine what it looks like. Yes, you're going to have more complications and things, so that'll fluctuate a little bit. But it's promising, right? And so this is the point of the video. This is showing that what is possible and that it doesn't take a ton of data. It doesn't take, a huge team of people and tons of money to do some of these things. Sometimes it's just small, tactful approaches that's going to make your AI a little bit better. And knowledge graphs can play a big role in all of that. All right, so with that, I really hope this video has helped you. If you are interested in anything that I talked about that I didn't go into enough detail, please let me know. And thank you so much for joining me. All right, so with that, I want to thank you very much, and I'll catch you next time.